Lab 3, the Monte Carlo Analysis. In this lab, we're gonna study about the analysis called Monte Carlo Analysis, which is used to assign the measurements which we have done in global parameters and tolerance and distribution. And we're gonna select some points or particular points of the parameter so that we can reach our near perfection. First of all, open the circuit. In the PSpice for the Monte Carlo analysis, we have like 4 functions: flat, Gaussian, BIMDA, and skew. The Monte Carlo analysis is like a key to the tolerances and the distribution in our circuit. The standard and the custom measurements are associated with the simulation profile. The steps in the Monte Carlos will be like just assigning the tolerance to the model parameters and configuring the AC or DC profile. Now apply the test measurement functions and then run the Monte Carlo. The parameters are so these are the all variables in our circuit profile. The variables are C toll, the R toll, resistance tolerance, L toll, V toll, I toll. The tolerances are defined locally or referred as globally. So as we have changed the C toll, we're gonna display the value of C toll as a 10. The R toll is the resistance tolerance. In this we have to change the distribution of resistance as a flat. We have changed the distribution to the Gauss 0.4. R toll, C toll is already 10, negative tolerance, positive tolerance 20%. So these are all the particular parameter changes we're gonna do for the resistance. So this is the distribution change of the values, tolerances. This is the negative tolerance, the positive tolerance, and the distribution of the values for the R3 is 0.4. So now select R2. In the R2, select the distribution of the values like Gauss. Click all for all the distribution as flat. Change it to the Gauss. The distribution controls how the Monte Carlo will vary the parameter. We can vary either it as a flat or a Gauss or a BMI. So this is the how we wanna distribute the properties for the Monte Carlo analysis. We have to change it for all Gauss of 0.4 resistance values, and give a positive and a negative tolerance, like 10%, 20%, whichever. Apply. Start a simulation. This is the AC and DC circuit, so we have to make a two. One is DC analysis, other one with the AC analysis. AC analysis. This is same as we had done in the previous labs. The AC sweep, DC sweep. AC sweep is like for linear logarithmic scale in the dB basis, starting point like 1 megahertz to 100 megahertz. This is the same settings we have done in our previous labs too. So that's why I'm not saying. And we have to just take care that when we start the simulation, before that we check that in the background whatever values we needed to change, we already set all those inside parameters. click on the measurement result. So we're gonna select the cutoff low pass 3 dB. So this is gonna be the low pass filtration. Another one should be the gain. So low pass 3 dB output. Click here to evaluate a new measurement. Max 1. V output. Max V dB out. Evaluate the measurement. Go in the selection for power. We are interested in power dissipation from the Q1, so this will be the one. And another thing is that we can see current going out from collector of Q1, so IQ1C. This is all the same as we do all the time in previous labs. So in the Monte Carlo analysis we will see the particular values. So we have selected all the DC and AC simulation, all the parameters for statistical information. And in the profile setting, we will set the number of runs. We select 100. So 100 times the Monte Carlo analysis will move on. And all these parameters are the WQ1 power dissipation, current from the collector Q1, cutoff low pass 3 dB, gain at the voltage. So that's how it started. The shootem random number generated, it begins with the same seed. Each time you will run the Monte Carlo, it will give the same results every time you run the simulation. So you can enter different random numbers seeds in the profile setting dialog. So seed value, it will take a time to reach to the values. Now as we have like specifications for like cutoff, specification for the gain, specification for the maximum level of the current should flow from the Q1, and maximum voltage power dissipation, this analysis will tell us that how much of these values are exceeding this limit, how much are inside the limit. So if the values are inside the limit, so that will the particular point of the parameter changes in the component value. So this analysis says that okay, that particular values if it's 10% tolerance, so from this to this is okay. The Monte Carlo information will open like 6 new columns, like means, standard deviation, 3 sigma, 6 sigma, and the median. This is what the parameters of the analysis which we gonna get in output from the Monte Carlo analysis. This will be our statistical data which you get a mean deviating from the standard value. So this is for the WQ1. This is for the AC cutoff low pass frequency. This is in the PDG format. We want in a C.D F format, cumulative distribution. It has two markers, the minimum and the maximum. The minimum is at where the graph reaches 0, and maximum where it's 100%. Now our requirement over here is 181.5 megahertz. 181.5 megahertz. So take your scroll the minimum. This is minimum maximum pro. Now move the minimum cursor. Select the minimum cursor. Scroll the minimum cursor to what the particular value. Just click on that. Click on 181.5 megahertz on the plot. One 181.5 megahertz. So this is the minimum value, which is the required in. Now see that if we place the cursor on the 68%, we are getting the yield. See in the statistical information, 68% yield means that 36% of the values are not meeting a requirement. Now for the gain, we see that for the WQ1 is required to be maximum should be like 50 milliampere. Power dash, which the maximum is 1 volt. So select 1. This display that for IQ1 it should be 50 milliampere maximum, and for AC sim it's at 181, and for the AC maximum gain, which must be 17 dB, so it's exceeding more than 17 dB, it's coming to like 18. Between 16 to 19 it's coming the value. So in the profile setting, change the number of bins Power consumption should Q1 should be maximum 1 volt. This is IQ1. Scroll down the minimum value to 17. This shows that we need to have changed the values. Now as we know that only problem is coming in the Q factor, so change at 5k. Because we know that the values are not coming appropriate as far as power dissipation is concerned, so we have to increase the resistance value, so we change it to a 5k. For the AC, it's coming to 68% of the yield. For the DC, we require Q1 to be 50 milliampere. Change number of bins to 10. Set up a Monte Carlo analysis for the bandwidth. So this analysis is completed. This is the cumulative distribution graph for like 1 to 100 runs. Now it's 0% yield, 0% yield for the DC stands that all the requirements are met as far as power dissipation and collector current is say if it's 50, if its power dissipation, its maximum is 1 volt. That means we are getting what we want. So yield is 99%. Same for the IQ one, it should be 50 milliampere maximum. So if you set the minimum maximum graph, we found it as collector current measurement to be 100% in yield. So this means that we are getting what we want. In the AC, 81% is coming for the maximum VDB or cutoff low pass. Select minimum as 181, which is required. It's coming to the 80%. So this is like the 80% chances that 3 dB is greater than 181.5. Select for the gain. It's coming to 59%. Now scroll down the minimum bar to 17 dB. So and maximum bar up to maximum, it's 100% yield. So if it's if I set it 17 dB, there's be 100% chances that we meet a requirement. So only 3% is probability that 7% probability that you don't meet your requirements. This might be acceptable because we are almost near to the 90% of the yield of our maximum specification. So I think so that we are quite meeting a requirement, quite close to our specifications. All the changes we did, like changing the 5k for the R3 resistance, because we need to increase that resistance in order to make our circuit to function well. So this is all the Monte Carlo's magic in order to know that what particular component will affect on the percentage yield or getting the satisfactory results for our main graphs, for our main design parameters, and for our design circuits.